Alright, today folks, we're going to continue working with our law of sines and law of cosines. Today we're going to specifically look at the law of cosines. Alright, so real quick, let's go back and review what law of sines, how do we know to work with law of sines. Alright, when you have law of sines, we know it's for a non-right triangle. But in order to be able to use law of sines, you have to be given an angle and the opposite side. Okay, so we have to have an angle and the opposite side in order to be able to set up law of sines. So what if we don't have that situation? Well, if we don't have that situation, then we're going to use the law of cosines. Alright, the law of cosines again is when you don't have a right triangle and you're not given an angle and the opposite side. Alright, so there are actually three parts to the law of cosines. So we're just going to write these down and then we'll try to figure it out. Alright, so copy these down and then we'll talk about it. Alright, about 20 more seconds. Alright, so the law of cosines. Alright, so you're going to have in a triangle the three sides given to you, so side, 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 or side, angle, side, where the angle is in between your two sides. Okay, now if you take notice, this first one kind of looks like the Pythagorean theorem, doesn't it? A squared equals b squared plus c squared. This first part kind of reminds you of Pythagorean theorem, b squared equals a squared plus c squared. And then c squared equals a squared plus b squared. Alright, so it is kind of like the Pythagorean theorem a little bit, and that it reminds you of it. Okay, but then we've got minus 2bc cosine of a. Let's see if we can figure out this pattern. We know we got side a, b, and c, so we got an a, and then on the right side, if a is on the left, then b and c are on the left side. I said that wrong, didn't I? You can tell it's late. Let's try it again. Alright. We've got a on the left side, and on the right side, we've got b and c. Then it says minus 2 times these two right here, bc, times the cosine of the angle opposite of the side you're working with. Right here, same pattern. We got a b. Then over here, we got an ac. 2 times that ac times the cosine of b, the side that we're trying to work with. All right, c squared. All right, here we got a and b minus 2ab times the cosine opposite of this side that we're trying to work with, opposite angle of the side we're trying to work with. Okay, so it's just really a pattern. I know when we see the rules like this, we get so hung up on the letters that we just don't recognize the pattern. So what I'm going to do for our examples today is I'm not going to put any letters in there. We're just going to start working with the pattern. Alright, so let's try our first example right here. Okay, so here we see that we want to try to find side X. All right. Now before I do that, let's see if we can determine if we've got side, 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 or side, angle, side. All right, side, side, side obviously is when you're given all three sides. And here we're not given all three sides, so no, it's not side, side, side. And side, angle, side is when you're given two sides. And notice here the angle's in the middle, so you're given the angle in between the two sides. And that's what we have here. We have a side, then an angle, and then a side. So this is a side, angle, side scenario. All right, just like before, we want to work with an angle and its opposite side. Okay, but we're not going to know the angle and the opposite side. We're going to know either one or the other. Okay. All right. So since this is the angle that I'm given and this is the opposite side I'm trying to find, these are the two main pieces. All right, so we're going to have our side squared is equal to the other two sides squared. So we got 10 squared plus 17 squared minus 2 times the numbers on this side, so 10 and 17, times the cosine opposite of that side. All right, so the cosine of this angle would be 100. All right, so again, what did I do? I looked at the angle and the opposite side. Now, if I knew that right there, I could use law of sines, but I don't know both pieces, so we're using law of cosines. So we're going to say the side squared is equal to the other two sides squared minus 2 times the two sides we know times the cosine of the angle that we're working with. Now, I just want x, so the inverse of squaring something is taking the square root. So I'm going to put all of this in Desmos. All right, so I'm going to come right here. I'm going to do the square root of 10 squared plus 17, plus 17 squared. Well, there we go. Minus 2 times 10 times 17 times the cosine of 100. Now again, make sure that your mode is in degree mode. If it's not in degree mode, you will get the wrong answers. All right, so we get 21.2. Okay, so here x is approximately 21.2. And there we go. So as you're copying this down or thinking about it, how did I know to use the law of cosines? Again, I was working with a triangle that's not a right angle, doesn't have a right angle, so it's not a right triangle. I know an angle, but I don't know the opposite side. Okay. All right, so since I know an angle and not the opposite side, I know I'm working with the law of cosines. If I knew the 100 and I knew what x was, then I would use the law of sines. All right, so give that one a try. Let's let that one be a you try. Now this one is almost identical to number 1. So what I'm going to do in this lesson, I'm going to work a problem together with you, and then I'm going to let you have a problem to try, just like the one that we just worked. So if you're watching the video, pause the video for about 2 to 3 minutes, and give this one a try. All right, so let's see how you did. Alright, so here's my angle and the opposite side. I don't know my side, so I'm going to say x squared is equal to the sum of the squares of the two sides I do know. So 27 squared plus 26.5 squared minus 2 times the two sides I know, 27 and 26.5, times the cosine of 66.1. Alright, so if this is x squared, I know I just want x, so I take the square root. But if I take the square root of the left side, I got to take the square root of the right side. So we'll come right here, square root of 27 squared plus 26.5 squared minus 2 times 27 times 26.5 times the cosine of 66.1. Alright, and here we can see, rounding it to the nearest tenths, we got x is approximately 29.2. So again, I noticed that this was a side angle side scenario, so it was a SAS. I saw that I was working with an angle and the opposite side, but I wasn't given both pieces of information, so that lets me know that I should not use the law of sines. I needed to use the law of cosines. Now, in number 1 and 2, we were looking for the sides. So let's see what happens if we look for the angle. Alright, so here's the angle I'm trying to find. So I've got my angle and I've got my opposite side. Alright, so let's set this up. Alright, so we've got the opposite side of 20.6 squared is equal to the other two sides, 15.2 squared plus, well, we don't know what that is, do we? So that's an unknown. Minus 2 times 15.2 times our unknown times the cosine of theta, which is also an unknown. So we've got multiple unknowns, so we can't just use it from the get-go. So this is actually a two-stepper. If you notice, we got side, angle, side. So yes, this one's a multi-step problem, so it is a more difficult problem than number 1 and 2. What we have to do first is we have to find this missing side. So let's just call that A. You can call it any letter you want. Alright, once we find A, then I can substitute into these two pieces right here, and I would only have one unknown. So step 1 is to actually find A. So we're going to say A squared is equal to my other two sides, 15.2 squared plus 20.6 squared minus 2 times those two sides times the cosine of the angle opposite of A. Alright, so we're going to take the square root of this. Alright, so let's see what A is going to turn out to be. Alright, so we got the square root of 15.2 squared plus 20.6 squared minus 2 times 15.2 times 20.6 times the cosine of 84.5. Alright, so we get A is approximately 24.4. So step 1 was to find that missing side. Alright, now that we have that, then step 2 is to actually come in here and figure this one out. Alright, so we got 20.6 squared, which is opposite of the angle that we're trying to find, is equal to the other two sides. So we got 15.2 squared, then we got 24.4 squared, minus 2 times 15.2 times 24.4 times the cosine of theta. Alright, now, this is a big old equation, isn't it? So we're trying to solve this equation. Now, we're just going to cheat a little bit. And I really shouldn't say cheat. We're going to cheat with time. Instead of solving it step by step, we're just going to use Desmos. This is an equation, and remember I told you that we could do left side, right side, and see where they intersect to use Desmos. Alright, so I'm going to come right here. This does not have a variable, so I'm going to do y equals 20.6 squared. And then, in line 2, I'm going to put this right here. Oops, might be helpful. Y'all can see it, right? Alright, so we got, let's go to line 2. 15.2 squared plus 24.4 squared minus 2 times 15.2 times 24.4 times the cosine. Now we can't use theta, so we got to use an x. Cosine of x. Alright, so now let's come right here and let's find out where they intersect. So let's find this. Alright, I'm going to change some colors here just so that we can see it a little better. So we want the first place they intersect. So the first place they intersect is right here. So what is angle theta going to be? It's going to be approximately 57.2. So 57.2 degrees. Now, as you can see, we've got our sinusoidal graph. That's it. So remember, sinusoidal could either be sine or cosine. This one is cosine because we see it starts with the amplitude, but we only want the first place that it intersects. So that's why we're choosing that point right there. Alright, so again, when you have a side angle side and you're trying to find the angle, but it's not the angle opposite of the side that you're given, then you have to do a two-stepper. You have to find the missing side first, and then you can find your angle. Alright, so let me give you one to try right here. This is going to be just like number 3. So number 4 is going to be a you try. So if you'll pause the video for about 3 minutes and see how far you can get. Hopefully you can get all the way. Alright, so let's see how you did. Alright, so right here is the angle I'm trying to find. So that's the angle, and there's its opposite side. So we would normally come in here, and we would say 9 squared is equal to the other two sides, so 16 squared plus, well, this is our unknown, isn't it? I'm just going to call this x. So that would be plus x squared minus 2 times 16 times x times the cosine of our angle. But again, we have two unknowns. And because we have two unknowns, we can't solve that. So we've got to figure out what x is first. So we're going to come right here, we're going to use these two right here to find out what x is. So step 1 is we'll say x squared equals the other two sides, 16 squared plus 9 squared, minus 2 times those two sides of 16 and 9, times the cosine of the angle that we do know, 91. Because 91 is opposite of x. So these two right here match. They should always be opposite of each other. Alright, we're going to take the square root of both sides. And when we do that, we're going to get x equals 18.5. So this right here is 18.5. So we figured out what that missing side was. So now we can come right here, and where we had our blank, we can put 18.5. Alright, so again, one more time looking at how to put this in Desmos. Let's see, so we can see both pieces here. Alright, this does not have a variable, so I'm going to do y equals, well, we know 9 squared is 81, so I'm just going to go ahead and do y equals 81. And then I'm going to do 16 squared plus 18.5 squared minus 2 times 16 times 18.5 times the cosine. Alright, can't use x. Can't use theta. We're going to have to use x. Alright, then we're going to come up here to our graph and find the first place that they intersect. Alright, the first place they intersect is at 29.1. So here, theta is approximately 29.1 degrees. Now again, that is one of our most difficult problems because it was a multi-step problem. This was also a side angle side because you were given a side and the angle in between the other side. So here are your two sides and the angle in between. So that was a SAS situation. I bet y'all rolling them eyes and giving me a little bit of sass on this one. Alright, just a few more. So we got going through 8 examples today. Alright, so if you'll copy this down. Alright, so what we notice here is we're given all 3 sides of our triangle. So this is a side, side, side scenario. And we are being asked to find our angle. So again, we want to work with the angle and the opposite side. We're not using sine on this one because we don't know the angle and the opposite side. We only know one of them. So we're going to use the law of cosines. So we're going to say our side that's opposite the angle squared is equal to the other two sides squared, so 12 squared plus 14 squared minus 2 times those sides, 12 and 14, times the cosine of our angle theta. Alright, so we've got an equation to solve, so we're just going to come in here, we're going to put it in Desmos again. Alright, so I'm going to do y equals 24 squared. Let's try that again. How about put a 24 in there? 24 squared, there we go. And then we'll go to line 2, and we've got 12 squared plus 14 squared minus 2 times those values. So 2 times 12. Oops, there's must be a square there too. Times 14 times the cosine of x. Alright, so let's find out where they first intersect. Alright, so they first intersect right there. So this angle is going to be approximately 134.6 degrees. So here theta is approximately 134.6 degrees. Alright, so let me give you a U-try that's just like this one. Alright, so if you'll pause the video for about 2 to 3 minutes and see what you can do with this one. Alright, let's see what you got done here. Alright, so here's my angle and the opposite side. So we got our side opposite of our angle, 20 squared, is equal to our other two sides squared, so 7 squared plus 22 squared minus 2 times those two sides times the cosine of our angle, which is theta here. Alright, when you put this in Desmos, you should end up with theta. It's going to be approximately 64.4 degrees. So again, left side, right side, and see where they intersect. Alright, we're down to our last 2 examples. Alright, so for these last 2, we want to find all the measures, so every missing angle and side. Alright, so we want to come right here, we want to find x, y, and z. Alright, so I'm going to start with the angle they give me and the opposite side. Alright, so step 1 right here, I'm going to have x squared is equal to my other two sides squared, so 17 squared plus 15 squared minus 2 times those two sides of 17 and 15 times the cosine of my angle 122. Alright, this is x squared, but I want x, so I need to take the square root. When you put this in your calculator and solve for it, we're going to get x equals 28. So this is 28. Alright, now I know this is called law of cosines, but now that we know the angle and the opposite side, we can actually come in here now and use the law of sines. So step 2, I'm going to say the sine of 122 over 28 is equal to, let's just do y, the sine of y over 15. So this is like what we were doing yesterday. All right, we're going to cross multiply. And I know that when I cross multiply and then try to solve for y, I'm going to end up with the sine of y equals 15 times the sine of 122. And then we end up dividing by that 28. Since we're looking for an angle, we're going to have to do the inverse. So I'm going to come right here. I'm going to do the inverse sine. Then I'm going to put all this right here. So put my fraction there. So I got 15 times the sine of 122 over 28. And that gives me that y is approximately 27 degrees. So this is 27 degrees. Now, our last step to find angle Z, that's the easy one. We know two angles of a triangle, and all three angles are supposed to equal 180. So to find Z, that's going to be simply 180 minus the sum of 27 plus 122. And let's see, that's going to give us what? 149 from 180. 149 minus 180. It's going to give us what? 31 degrees. So Z is equal to 31 degrees. And this scenario right here was a side angle side. All right, our last example is a U-try for you. It's going to be just like number 7. All right, so let's see. 26, 17, 112. Let's call this X, Y, and Z. Alright, so if you'll pause the video here for probably about 4 minutes, since this one's a 3-stepper. Alright, so let's see how you did. Alright, so again, I'm going to start with the angle and the opposite side. Alright, the pattern says it's your side squared, so we got x squared is equal to the other two sides squared, so 26 squared plus 17 squared minus 2 times those two sides times the cosine of the angle opposite of our side. So that would be 112. That's x squared, so we need to take the square root. And when we do that, we're going to get x equals 36. So that was step 1. Alright, step 2. Now that I know an angle and the opposite side, I can go back and use law of sines. So I'm going to say the sine of 112 over 36 is equal to, let's do y, the sine of y over its opposite side of 26. So cross multiplying, we're going to end up with the sine of y equals 26 times the sine of 112, and then we end up dividing by that 36. Since we're looking for the angle, we know we have to use the inverse. So when we put it into Desmos, we'll do the inverse sign, and then put this in Desmos. And when we do that, we're going to get y is approximately 42 degrees. All right, and then for our last step, we now know two angles of a triangle, and we know that all three angles are supposed to equal 180. So to find Z, we're simply going to say 180 minus the sum of our two angles. All right, so 112 and 42 give us what? 154. And taking that away from 180 gives us 26 degrees. And there we go. All right, so make sure that your notes have your name and date on them and submit them.